know, cats do their own thing. They are not big fans of like obeying. So if you are trying to herd cats, it's gonna be problematic. So we're gonna use this example of cat herding as a way to talk about a concept called percent yield. So we have two scenarios we're gonna work with. In scenario one, Miss Lestick, she's a teacher down the hall. She teaches chemistry down the hall. Miss Lestick is trying to herd 200 cats from her home in Austin all the way to Round Rock High School. So she lives in Austin, like close to UT campus, close to downtown. And she has to drive all the way up 35 to come here to work every day. And drive home all the way down 35. Yeah, it's not great from what I understand. But she wants to herd 200 cats all the way up 35 to come up to Round Rock High School.
I'm just picturing in my head and it's hilarious.
In theory, in a perfect world, gentlemen, in theory, in a perfect world, how many cats would make it all the way to Round Rock High School? She starts with 200, and in a perfect world, how many of the cats make it here? 200. That's our perfect world scenario. We have a name for that perfect world scenario. That's called a theoretical yield. That's called a theoretical yield. If the world was all rainbows and sunshine, and if everything was perfect, then that would be a theoretical yield. So we're going to abbreviate this TY. TY, theoretical yield. Okay, that's our rainbows and sunshine perfect world scenario. But the world is not perfect. In the real world, if you're trying to get 200 cats to go all the way up the interstate for like, I don't know, 10 miles or however far it is, 15, 20, I don't really know exactly how far away she lives. But if you're trying to go all the way up 35 with 200 cats, how many of the cats are going to make it? Are all 200 going to make it?
-5.
No. In the real world, some of those cats are going to get distracted. They're going to climb trees. They're going to chase mice, okay, or squirrels or birds or whatever. Some of the cats escape. Not all of them are going to make it to Round Rock High School. So maybe only 189 cats make it. That's called the actual yield.
That was actually happen. That would still be impressive.
Well, yeah, I agree. That's a very optimistic actual yield. And we abbreviate that AY. So that's not our perfect world scenario. That's our real world scenario. Instead of sunshine and rainbows, it's sad little rain clouds. The percent yield is a ratio of what you should get in theory compared to what you actually get. So the actual yield divided by the theoretical yield times 100. This is our formula for percent yield. This right here is the formula that we're going to use. And you do not have to memorize this formula. I will make sure to give you this formula on quizzes and tests. You do not have to memorize it. Okay? But there's our formula. So basically the real world smaller number that's not as good as we want it to be, divided by the sunshine and rainbows perfect number, and then you times 100 to get it to be a percent. So in this first cat scenario, the 189 cats that actually make it, divided by the 200 cats that we wish had made it, times 100. And if you stick that in your calculator, you would get 94.5% of the cats made it to the school. So let's look at a second scenario. What if, once those 189 cats get to the school, all the chemistry teachers together decided that 75 of those cats need to go to Miss Nichols' office for a nice surprise? So in a perfect world, how many of those 75 cats would make it to her office? 75. So that's 75. That is our theoretical yield.
Yeah, what time is it? What page is it?
This is page 18. Those 75 cats, those are our theoretical yield. That's our sunshine and rainbows perfect number if the world were perfect, which unfortunately it usually is not. Okay, that's our sunshine and rainbows theoretical yield. And the problem says only 73 of the cats make it, somewhere between the 600 and the 1200. 2 of the cats go chase a squirrel or something. So what is that 73? That's our real world number. What is that called? The actual yield. So that's our sad rain cloud number. Okay? And the percent yield is what they want us to find, percent yield. That's this formula up here, where we take the actual divided by the theoretical times 100.
Why is my phone look angry?
Okay, so what are we going to plug in on top of our fraction? Which number? 73. And then on the bottom, which number are we plugging in? 75. And then times 100. Go ahead and stick that in your calculator.
You do it the other way around.
Then you're going to get a percent over 100, which is probably not correct. I'm going to say 99 times out of 100. That'll tell you that it was upside down. Remember, we round to 2 decimal places, and if you typed it correctly in your calculator, this is what you should have gotten. You say do you have a question? Okay, just checking. Okay, so let's take this idea and think back to chemistry. Just like cats, not all atoms from the start, not all reactants make it to the end. Not all reactants become products. Some of them just don't react. Or they get spilled or whatever, and whatever reason, they don't turn into products. In theory, in a perfect world, all of your reactants become products. And in theory, your theoretical yield will be your perfect world thing. To find that theoretical yield, we need a mole bridge. To find that theoretical yield, we need a mole bridge. Caitlin, do you and Brianna have a question? Reagan, did you and Bree and Jada have a question? Somebody back there, I thought, must have a question, so I just want to make sure. In actual labs, not 100% of stuff becomes products. Some of it gets spilled, some of it just doesn't react for some reason, whatever. So your actual yield would be the amount produced in the lab, and it's usually going to be a number of grams. Usually it's going to be a number of grams, and it will always be a product. It will never be a reactant. It's a number of grams of product. When you're done writing that, go to the top of 19. That's the next page. I'll hold my book here for a second if you're still catching up to me.
It's 355, right?
It currently is, but I'm not quite done yet, so you're going to have to wait.
Would it be possible if you just give me the rest of this and I can study it?
No, I need you to be following along.
How long is it going to take to finish page 19?
Well, it would be faster if I were doing it right now. So, okay, can I move my page? Are you ready? All right. So number 1 at the top of this page says calculate percent yield for the reaction above. When 534 grams of carbon dioxide reacts to produce 645 grams of carbonic acid, that's H2CO3. When they give you 2 numbers, you will probably find it easier to do the problem if you label both of them in the reaction. So 534 grams of carbon dioxide, which one of these things is carbon dioxide? The first one. So you're going to find it will make your life a little easier if you label it. And 645 grams of carbonic acid, they tell you that's this H2CO3. So label that one 645. Okay, and the important thing here is that yields are products. They cannot be reactants, they have to be products. Yields have to be products. So when they ask what is the percent yield, and our formula says we take actual yield divided by theoretical yield times 100. The only stuff we can plug into that formula is products. We cannot plug reactants into that formula because a yield has to be a product, and everything in this formula is a yield. Everything in this formula is a yield, which means all of it has to be a product. So this 534 Can I plug 534 into this formula anywhere?
No,
No, why not? What's wrong with this 534? Someone besides Andy.
no. Fine, normal.
This 534 is a reactant. It cannot go in this formula. So here's what you do. You use a mole bridge and turn it into a product. And what you get from the mole bridge will be your theoretical yield. That's what we just wrote down at the bottom of page 18, that the theoretical yield uses a mole bridge. So what we get from that mole bridge, our answer from that mole bridge, will be a theoretical yield. And this number that was already a product that they gave me, if we read, it says that the reaction proceeded and produced 645 grams. That's how much was actually made. That is my actual yield. So when I come down here for this formula, I can plug in that 645 grams as the actual yield. But to know what's going to go on the bottom, I have to follow a mole bridge first. And when I finish the mole bridge, my answer from the mole bridge is going to be what goes on the bottom here.
Long story short, the problem is made out of two smaller problems.
Yes, but Andy, sometimes those kind of comments are not constructive. Okay, that means to get our answer from the mole bridge that we can plug into the bottom here, we're going to have to do 4 fractions. Start at the edge or you're going to run out of space. We're going to start with that 534 grams of CO2. Number they gave us is always over 1. And we need to find grams of the product, so we're going to find grams of H2CO3. That's what we're looking for. They asked for grams of the product, so grams of H2CO3 is what we're looking for. What goes up must come down, so 5 grams of CO2 on top. Where else are they getting written? On the bottom diagonal, yep. Okay, how many times can I use grams in a row? 2. Only 2, so that's already 2. What do I switch to?
Moles.
Moles, good. And when grams and moles are in the same fraction, the chemical has to be the...
Product.
The chemical should be the same. So the bottom was CO2, the top should also be CO2. And when grams and moles are in the same fraction, what number should we have for moles? 1. And where do grams come from? The periodic table. So you're going to do C and O2 and add them up. And for the sake of time, I'm going to go ahead and just tell you that should come out to be 44.01. I'm just saving you some time right there. Then, what goes up must come down. So moles of CO2 are going to come down here. And once you have moles on the bottom, that's your signal. You're ready to use the mole bridge and switch chemicals. So we're starting with CO2, and what chemical are we supposed to be ending with? H2CO3. So we're going to put H2CO3 on top. And when we switch chemicals, the unit has to be in the fraction, both parts of the fraction. When we switch chemicals, both of these units need to be moles. And we got really lucky in this problem because there's not a number written in front of either of these, which means what number of moles are we using? 1 for both of them. How convenient. And then what goes up must come down?
And you can only use 4 in a row.
4 moles in a row, yep. So that's good that we're switching to grams on top. When grams and moles are in the same fraction, they should be the same chemical, so that's good that we have that there. And moles should be what? 1. Grams and moles in the same fraction should be 1 mole. Grams come from where?
Periodic table.
Periodic